Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everybody. Today, inshallah, we'll complete our lesson about organic chemistry. Let's see. Today, inshallah, we'll continue to complete our lesson about hydrocarbon. As we know that gasoline, diesel fuel, and kerosene are examples of liquid fuel. A solid fuel like coal produces steam for locomotives that pull old-time trains. These fuel are mixture of what? Of compounds called hydrocarbons. You will learn about the structure and properties of hydrocarbons. We talked about hydrocarbon in the previous session, but today inshallah we'll know more and more about them. Let's see. How is the number of valence electron in carbon atom related to the bonds that carbon atoms are formed? Yeah. We talked the last session about what carbon. I told you that carbon has 4 valence electron. 1, 2, 3, 4. Right? So these 4 are supposed to be 8 to be complete. Now they will make 4 covalent bonds with 4 hydrogen atoms. So we'll share with hydrogen, share with hydrogen. All of us know that hydrogen has only 1 electron, right? Okay, guys? Okay. So what now? We can see 4 valence electron. Right. We can see now what? We can see 4 valence electron. 1 bond, 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 bond. So we can write it in another way like that. And each dash represents what? Bond. Single bond. Why single? Because only 1 pair of electron. Each atom share only with 1 electron. So it's a single bond. Right? Okay. Because carbon has 4 valence electron, we said that they can form what? Carbon atom always form a 4 covalent bond. 4 covalent bond. The simplest organic compound contain only carbon and hydrogen like we did now. So are called what? Hydrocarbon, because they made only of hydrogen and carbon. Yeah, exactly. Right. So guys, so we call them hydrocarbon. Look here, 1 atom of carbon has 4 valence electron and 4 hydrogen atom. They will share together with only 1 electron to make, yes, very good organic compound, or the simplest kind of hydrocarbon. It's a methane molecule. Methane molecule. Easy till now? Right. So carbon plus hydrogen give me methane molecule. Formulas and models for methane and ethane. What the meaning of methane and ethane we will know now. Guys, look here. We talked about structural formula. It shows us how they are connected together. The atoms, carbon and hydrogen, how they are connected together. Right, like the methane, CH4, CH4. Can you see? This is the original formula, or ordinary formula we write. But here is what the structural formula show us how the carbon is connected to the hydrogen. Right. Second one, ball and stick model, like we saw before in the lab. How they are connected together, right? Ball and stick model, this model, and what else? Space filling model, the third kind of models, of course. But we will talk more about what structure formula. The methane, can you see? The ethane, sorry, 2 carbon atom, and each one connected to 3 hydrogen atom. And remember that each carbon supposed to be surrounded by 4 bonds. Surrounded by 4 bonds. Remember that each carbon supposed to be surrounded by 4 bonds. By 4 bonds. Okay. Ethane in ball and stick model, and ethane in space filling model also. Easy till now? Okay. What are 2 possible arrangement of carbon atom in an alkane? Remember that. In that section, inshallah, in this section we will talk about alkane only, right? We will take alkane only. So please focus and concentrate with me. So we'll talk about what? Alkane. An alkane, guys, is hydrocarbon in which there are only single covalent bond. As we talk or learned before, we know that carbon can make single bond with another carbon. So it's what alkane. Maybe make double. So it's alkene. Maybe make 3 bond with another carbon atom, so it's what? Alkyne. But today, inshallah, we will not talk about alkyne or alkene. We will talk about only what? Alkane, the single bond. Single bond. Okay? Right. The carbon, guys, atoms in an alkane can be arranged in a straight chain or in a chain that has branches. As we talked the previous lesson, we have a straight the carbon backbone. We have a straight backbone and branched, right? Okay, we have a straight chain and branched chain. Yes. So we repeated the words and the information today again. The carbon may be like that, straight chain, or maybe like that, branched, like what? C, 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 and you can find a branch come from here, branch come from here, so it's branched. Okay? Right. Thank you, guys. Alkane. Straight chain alkane. Ethane is the simplest. So we're talking what about ethane? Ethane is the simplest chain, because in a chain, the simplest chain consists of only 2 carbon, because 1 carbon cannot make a chain, right? It's just 1 carbon, but to make a chain, at least you need what? 2. So the simplest chain in hydrocarbon is for the ethane. The ethane is the simplest of a straight chain alkanes, which contain any number of carbon atoms, one after the other in a chain. Look here, 2 carbon atoms, each one. I told you, listen to understand well. I told you that each carbon need 4 bonds, right? We have now 2 carbons. So this carbon will make bond with this carbon, right? So this need 3 hydrogen, and this need also 3 hydrogen. So 2 carbon need what? 6 hydrogen. Can you see? All of them, they are single bond, single bond, single bond, single bond, single bond. All of them single bonds. So 2 carbon plus 6H, they will share each other. Carbon will share the carbon with 1 electron, with 1 pair of electron, right? So still have 3 here free and 3 here free. The 6 hydrogen atom will complete these spaces. The final form will be like that. Each carbon had 3 atoms. For example, this carbon has this and this and this hydrogen atoms, and another bond with the other carbon atom to make a chain, because it cannot be separated. The chain is supposed to be connected. The carbon is supposed to be connected to each other. There is no chain if the carbon not connected to each other. So there is no chain if I did like that. CH, for example, Of course, it's not working because H has the can make only one bond, so it's wrong. So the chain is supposed to be C attached to C. Okay. Easy till now? Okay. Let's complete, guys. We will talk about the names of alkanes and the prefixes. A group of a compound form a homologous series if there are a constant increment of a change in molecule structure from one compound in the series to the next. Listen here. The first one was CH4 because each carbon needs 4 bonds, so it will attach to 4 for what? Yes, 4 hydrogen atoms. The first one, CH4, is called methane. Second one, yeah, CH3 will be ethane. Third, propane, CH3H8 or CH2, CH3. Number 4, butane, CH10, CH3, CH2, CH3. And we will know now why we put CH3 and CH2, why. And if we have a chain of 5 carbon atom, it's pentane. If we have a chain of 6 carbon atom, it's a hexane. If we have 7 carbon atom, it's heptane. If we have 8, it's octane. 9, nonane. 10, decane. Yes. Okay. And why we put these prefixes and why we start all the time, except of course methane, with CH3 and end with CH3, and in the middle we find all the time CH2, but in the two sides CH3 and CH3 in the beginning. The two sides start and end with CH3, except of course methane, because it's only one carbon, not chain. Look here, guys. Why we start with CH3? Because I told you that each carbon atom needs 4 bonds. So 1, 2, 3, H, and H. To make a chain, will attach to another carbon atom, right? And this carbon is needed to attach to hydrogen atom also. So CH3 and CH3, and this is what the ethane. The ethane, CH3, CH2, H6, C2H6 or CH3, right? Okay. If we want to make a chain of 3 carbon atom, C, and C. Look here, guys. This need what? 3 hydrogen. This in the middle need what? No, only 2. Why? Because it has already 2 bonds. One here with the carbon atom here and one here. So it needs only 1 hydrogen here and 1 hydrogen here. Now it's surrounded by 4 bonds, so it's complete. Now the last one has only 1 bond, so I will complete it with 3 hydrogen atom. In that case, we have CH3, CH2, CH3, right? And so on. So guys, we know that the 2 sides, because they are the last atom, they have to be attached to 3 hydrogen atom. But in the middle, they already have 2 bonds with the carbon on the right and on the left. So they need only 2 hydrogen atom. So we start here with CH3 and end with CH3, but in the middle we can find CH2. Very good. Thank you. Alkane, guys, we can use alkanes as fuel, like propane and butane. We use most of alkane as fuel. Okay. We talked about the structural formula. Now we will talk about what condensed structural formula. Some bonds and or atom are left out of the structural formula, although the bonds and atoms don't pair, they are there. Okay, how that? Let's see. We here show you some formulas and how to write the formulas of organic compounds. The first one, the ordinary formula, the molecular formula, C4H10, C4H10. The structural formula, it will be C4. C4 means chain of 4 carbon. C1, 2, 3, 4. 4 carbon, and each one attached to hydrogen carbon. Of course, the two sides attached to 3, and the middle attached only to 2. Right. Condensed structural formula. C bonds with hydrogen. Bond unrestored. This is what the condensed structural formula. We write each part of carbon alone. CH3, CH2, CH2, and CH3. Is it now? Right. Maybe condensed formula written without bonds, without dash, like that. CH3, CH2, CH2, CH3, without dash, like here. Condensed structure, we can write it in another way by using subscript. I can see here CH2 is repeated two times. So I can write it what? CH3, CH2, all 2. I write subscript and CH3, like math, you know that. Carbon skeleton, all hydrogen and carbon bond together. Of course, I told you that to make a chain, the carbon, they are connected together. Line angle formula, you can write the formula by using line angle formula. All carbon and hydrogen and restored carbon atom are located at each intersection and at the end of the line. Maybe C, 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 like that. Right? Okay. So let's take another one. Like C5H12. Right? We can write it. This is the molecular formula. This is what? The molecular formula. We can write it as a structural formula, like what? How many carbon? C, 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 C. 5. The two sides, of course, will attach to 3 hydrogen to make 4 bonds. The two sides. Right? And the carbon in the middle will be only, yes, 2 carbons. 2 hydrogen, sorry. Right. We have, can we write the condensed structure? Yeah. The first part is CH3. This is the first part. The second is CH2. The third is CH2. The fourth, very good, CH2. The last part is CH3. Of course, we can add dash or not. Both are correct. We can write it another way. CH3 brackets CH2 to all three, because we have CH2, 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 1, 2, 3. So 3 times we will write subscript of 3 and CH3 by the end. Is it till now? Okay. Drawing structure formula for alkane. Draw a complete structure formula for a straight chain alkane that have 3 and 4 carbon. Let's see how they are. How can we write or draw them? He gave you the steps here. In alkane, each carbon atom form 4 covalent bonds. We know that, to a hydrogen or to the other carbon atoms. Because of these are a straight chain alkane, yes, the appropriate number of or suitable number of carbon will be written in straight line and then connected to each other by single bonds. The chain will then filled with hydrogen. So you can write the chain, the carbon first, carbon, how many atoms? 3, for example. Yeah, we have 3. C, right? 3. We made here the chain. After that, you can fill the bonds with hydrogen. As I said, the two sides need 3 hydrogen. Very good. Can hear you. And the middle need only 2. And we did the structure formula for 3 carbon atoms. Oh my God, as we just answered now, we put what? The 3 carbon, right? And be sure that each carbon atom is surrounded by 4 bonds. 1, 2, 3, 4. And this one, 1, 2, 3, 4. And this carbon, 1, 2, 3, 4. All of them, they are surrounded by 4 bonds. The same here we'll do in the 4 carbon chain. 1, 2, 3, 4. And all of them will be surrounded by hydrogen atoms, by single bonds. Is it now? Okay. And draw a complete structure formula for the straight chain alkane with 5 and 6. Please try to pause the video and try to do it alone, because I will do it now. Look here, 5, you want 5 carbon, right? So it's 1, 2, 3, 4, 5. It's easy. I told you that each carbon surrounded by 4 bonds. Just to complete. H, H, H. Very good. Very simple. Very simple. It's bentane. It's what? Bentane. Because as we said a few minutes ago, bentane has 4 carbon atom or 4 carbon chain. Yes, chain, straight chain with 5 carbon atoms. Okay, it's a bentane. And 6 carbon command will did the same here, only will add another carbon atom. It's so easy. And that we have to take today, and thank you for watching the video. Thank you, goodbye.